Welcome viewers, in this video we will see the solved problem based on the losses and efficiency of the transformer part 2. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive, link is given in the description box. Now we will go to the problem. Find the all day efficiency of 1500 kVA transformer whose copper losses and iron losses at full load are 4.5 kilowatt and 3.2 kilowatt respectively. During the day of 24 hours, it is loaded as follows. So this number of hours is given, load in kilowatt and power factor. For number of hours 6 means the load in kilowatt is 1200, the power factor is 0.8. The number of hours 10, the kilowatt is 900 and the power factor is 0.75. And the number of hours 4, the load is 300 and power factor is 0.8. For another 4 hours, there is no load and no power factor. So this is the data given for entire 24 hours. By adding this, we can get 24 hours. So we need to find the all day efficiency. I will see the given data. So the 1500 kVA is given. The rating of the transformer is 1000 kVA. At full load, the copper loss and iron loss is given. Copper loss is 4.5 kilowatt. Iron loss is 3.2 kilowatt. So the full load output is 1500 kVA. Full load copper loss is 4.5 kVA. Full load iron loss is irrespective of the load. So the iron loss equal to 2.2 kilowatt. This is 3.2 kilowatt, not a 2.2 kilowatt. It is 3.2 kilowatt. So the all day output, we need to find the efficiency. For finding the efficiency, we need output and input power. So first we will find the all day output in kilowatt. So from the tabular column, for first 6 hours, the output is 1200. For next 10 hours, the output is 900. For next 4 hours, the output is 300. For another 4 hours, the output is 0. Right? So these data are multiplied. Finally, we got 17,400 kilowatt for a 24 hours. 17,400 kilowatt. So we calculated the output. Now we need to calculate the input. Right? So the iron loss for 24 hours equal to 2.2 into 24 means 76.8 kilowatt hour. Iron loss in 24 hours is 3.2 into 24, that is 76.8 kilowatt. So now we calculated the output and iron loss for 24 hours. When the copper loss, when full load copper loss is given, then the copper loss at particular load we need to find, because it is given for the hours, 10 hours, 6 hours are given. So the full load copper loss is already given, but we need to find the copper loss at a particular load. So how will you find full load copper loss multiplied by load kVA divided by actual kVA square. So by finding this, we can find the copper loss for a particular period, because in tabular column is given. Right? So the load kVA and actual kVA. How will you find the kVA? kVA equal to kilowatt divided by cos pi, that is power factor, kilowatt divided by power factor. So the load kVA and actual kVA we can use by this formula, kV divided by power factor, so that we can find the copper loss for a particular load. So copper loss for 24 hours is 6 into 4.5. So this is the 6 hours. This 4.8 is the copper loss for a kVA. This is the kVA is 1200 divided by 0.8. So this is the loaded kVA divided by actual kVA is 1500. Right? So this is the number of hour. This is copper loss, full load copper loss. This is the kVA rating given. This is kVA for this 6 hours divided by power factor. So that it is divided by power factor is square. So that we will get the copper loss for this 6 hours. Similarly, for the next 10 hours, the copper loss, that is 4.5, it is 900. For the next 10 hours, the kVA rating is given 900 and power factor given 0.75 divided by 1500 square. Similarly, for the next 4 hours, the rating is given 300, power factor is 0.8 divided by the actual kVA is 1500. The square is there. right? So this is the copper loss calculated for 24 hours. 6 hours, then next 4 hours, next 10 hour, and next 4 hour. Remaining 4 hour the power is 0, right? So this first term refer the number of hour. Second term refer the copper loss, full load copper loss. This one is nothing but kVA rating. This is the kVA for the particular 6 hours divided by power factor for the particular 6 hours. So all the data are multiplied. After simplification we got 56.925 kilowatt. So this is the copper loss for a full load for a 24 hours. This 4.5 is the copper loss for a full load copper loss. This is for a particular load for a given time period. It is multiplied and we calculated the copper loss for entire 24 hours. Now we got the output power as well as losses. From that we can able to find the efficiency. All day efficiency is nothing but output in kilowatt hour divided by input in kilowatt hour. Output in kilowatt hour, this input is written as output in kilowatt hour plus iron loss and copper loss, because output is available, kVA rating is given, input is not available, so that input is converted into output plus losses, right? So the output is 17,400 that we already calculated, divided by 17,400 plus 76.8. This is nothing but a iron loss for a 24 hours plus 56.925. This is nothing but copper loss for 24 hours. So output divided by output plus iron loss plus copper loss is nothing but a efficiency. So after simplification we got 99.24%. So the efficiency, all day efficiency is 99.24%. So in this problem we calculated the all day efficiency for a given particular tabular column is given, for the load condition is given, based on that we calculated. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is available in the description box. Thank you for listening.